Hi everyone, in this video I'm going to talk about different atmospheric layers and how the temperature, pressure, and density change within the first two major layers. Earth's atmosphere has five major and several secondary layers. From lowest to highest, the major layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. In this lecture, we're only interested in the first two layers. Temperature decreases with an increase in altitude. This rate is 6.5 degrees Celsius decrease if the altitude increases 1,000 meters, or 1.98 degrees Celsius in each 1,000 feet increase in the altitude. However, this is true only in the troposphere layer. And after that, with an increase in altitude, the temperature doesn't decrease and it remains constant. If we have altitude in the y-axis and the temperature in the x-axis in degrees Celsius, and at the mean sea level, we have the standard temperature equals 15 degrees Celsius. So when we are at the mean sea level, where the altitude is equal to 0, then the temperature will be 15.15 degrees Celsius. And from that point, temperature decreases as altitude increases up to a point which we call it tropopause and has an altitude of around 11,000 meters, which is equal to almost 36,000 feet. And the standard temperature at tropopause is equal to minus 56.5 degrees Celsius. And from tropopause upward, the temperature remains constant. So this layer is the troposphere, and here will be stratosphere. So using this ratio, we can find the temperature at any altitude within the troposphere layer. And the equation will be the temperature is equal to 15.15 degrees Celsius. So this number is the temperature at mean sea level. And then as the altitude increases, the temperature decreases. And it decreases 1.98 degrees Celsius with 1,000 feet increase in altitude. And in here, H has to be in feet. Or we can say T is equal to 15.15 again. If we have the altitude in meter, then it decreases 6.5 degrees for each 1,000 meter increase in altitude. We can also find the standard pressure at a given altitude using these equations, where here the first equation is for the troposphere and the second equation is for the stratosphere. P0 is the pressure at the sea level, which is equal to 1013 hectopascal, where a hectopascal is 100 pascal. And T0 is the standard temperature at sea level, G0 is the gravity, and R is the gas constant, which is equal to 287 joule per kilogram Kelvin. And also alpha is the temperature decrease ratio and is equal to this number. And in this equation, for the stratosphere, P1, H1, and T1 are for the values for at the tropopause, where the standard pressure at the tropopause is 226 hectopascal and the temperature is 216 Kelvin. And we know that the height of the tropopause is equal to 11 kilometers. And finally, the standard density is always obtained using the ideal gas law, where rho is equal to pressure divided by gas constant times the temperature, where here pressure is in Pascal and temperature is in Kelvin. And R, the gas constant, is the same as this value here. Now we can define temperature, pressure, and density ratios. The temperature ratio is the temperature at a given altitude divided by the standard temperature at the sea level. The pressure ratio is the pressure at a given altitude divided by the standard pressure at mean sea level. And the density ratio is, again, the density at a given altitude divided by the density at mean sea level. We can also find the density ratio by dividing the pressure ratio, and the temperature ratio. Note that here, to find the temperature ratios, temperatures has to be in Kelvin or Rankine, both of the temperatures. So now we can have equations for temperature, pressure, and density ratios variations below the tropopause and also above the tropopause. So the ratios are the temperature ratio, the pressure ratio, and also the density ratio. Below the tropopause, this is the equation for the variation of the temperature ratio, and above the tropopause, since the temperature is constant, so the temperature ratio will be constant as well. And for below the tropopause, we can find the pressure and density ratios based on the temperature ratio. Oh, sorry, it's not rho here, it's sigma. We show the density ratio with sigma. So these two are the relationship between the pressure ratio and the temperature ratio below the tropopause. And above the tropopause, we have these two equations. Now let's solve an example here. Consider a flight in the following conditions. The altitude is 33,000 feet. The actual temperature is minus 41 degrees Celsius. And we want to know what is the flight operation conditions. So the first step is to find the standard temperature at a given altitude of 33,000 feet. So we use the equation that we have before, where here h is equal to 33,000. So this will be almost equal to minus 51 degrees Celsius. So the standard temperature at the given altitude is equal to minus 51 degrees Celsius, while the actual temperature was minus 41 degrees Celsius, which is 10 degrees above the standard temperature. So we can say that the flight is operated in ISA plus 10 condition, which means that the temperature is 10 degrees Celsius higher than the standard temperature.